Welcome back to the deep dive. Today we are plugging into a specific, really quite brutal moment in musical history, a brief period in the early 1980s.
Yeah.
When the bedrock of the American guitar effects industry really began to crack under some pretty extreme economic pressure. We are talking about the budget war, where established heavyweights, masters of metal and military-grade construction suddenly found themselves, fighting for survival.
It was more than just a market shift, wasn't it? It was almost an existential crisis for companies like MXR.
Yeah.
Our sources really highlight that by the dawn of the 80s, the whole market landscape had just been fundamentally altered by this overwhelming flood of Japanese plastic pedals.
Right, those brightly colored things that were suddenly everywhere.
Exactly. Lines like Arion, Ibanez's budget stuff, Boss, and many others. They offered, pretty high-quality effects at a cost point that the American giants, who were still kind of relying on these expensive heavy metal boxes and, intricate hand wiring.
Yeah, built like tanks, but expensive tanks.
Precisely. They just couldn't match the price.
You really nailed it there. MXR was, globally known for classics like the Phase 90, the Distortion Plus pen, all built incredibly tough.
Indestructible, almost.
But when consumers are suddenly offered something that does basically the same job for, a fraction of the cost, even a legendary reputation starts to buckle, doesn't it?
It does. MXR had to respond, and they had to respond fast.
Yeah.
Which meant, maybe abandoning some of that metal legacy, at least temporarily, for a budget offensive.
Exactly. And this brings us directly to the line we're analyzing today, the MXR Commande series, which ran only briefly, didn't it? From 81 to 84, something like that.
That's right, 1981 to 1984. This series was MXR's direct, lower-cost strategic pivot. It was a calculated risk, really, aimed at surviving that immediate, intense budget competition.
A real demonstration that even the legends sometimes have to, swallow their pride and embrace plastic.
They had to adapt or die, essentially.
So our mission today is to really dig into the specific era of, panic and innovation, maybe.
That's a good way to put it.
We want to understand the series' unique and, let's be honest, often criticized construction DNA. The physical compromises MXR had to make. And then we'll analyze the 7 specific pedals, from dynamic boosts to surprisingly true stereo modulation that MXR managed to squeeze into this low-cost format.
7 pedals in just a few years.
Yeah. And this series is just a perfect example of, sophisticated analog engineering being trapped inside a chassis that was fundamentally built to a price point.
Right.
It's a story that ends, pretty tragically, with the original MXR company closing its doors in 1984, right around the time this series was discontinued.
It really is a fascinating case study. Corporate economics meeting raw engineering talent under immense pressure.
Okay, let's start with the hard reality then. Money.
How
do you take that classic MXR design philosophy and make it cheap enough to compete with all those imports flooding the market?
Well, the core of the strategy wasn't just about using cheaper components, though that was part of it. It was fundamentally changing how the pedal was physically built and assembled.
Less hands-on work, more automation.
Exactly. The philosophy of cost reduction was absolutely paramount, and it had to center on streamlined manufacturing. Traditional MXR construction involved chassis-mounted hardware.
Meaning the jacks, the pots, the switches, they were all bolted to the metal box.
Right. Physically secured to the heavy metal box, and then hand-wired, often point-to-point, to the circuit board inside, which is super robust, great for longevity.
But slow and expensive, labor-intensive.
Hugely labor-intensive, which brings us to the big leap MXR made with the Commande series, the shift to PCB-mounted hardware.
Okay, explain that. What does PCB-mounted mean in practical terms?
So to achieve that necessary lower cost line status, MXR moved pretty much wholesale to an internal architecture where components like the input-output jacks and the potentiometers, the knobs, the pots were soldered directly onto the printed circuit board, the PCB.
Ah, okay. So instead of wiring from the jack to the board, the jack is the connection point on the board.
Exactly. This speeds up assembly dramatically. Almost everything can be machine placed and wave soldered in one go. It's a massive manufacturing efficiency gain. Cuts down labor costs significantly.
But the most obvious change, the thing you see immediately, was the material for the shell itself. This just screams early 80s budget design. That plastic.
Oh, yeah. Lexan plastic.
Yeah.
Polycarbonate. That was the defining visual and structural element.
Why Lexan specifically?
Well, it's cheap. It's lightweight. It's really easy to injection mold into complex shapes. So it hit all the necessary cost targets for a budget line.
Makes sense. But was it just about being cheap, or did they try to add some finesse to the plastic design?
That's what's often overlooked, actually. Yeah. Even while making this major concession on durability, and it was a concession, the MXR engineers incorporated some genuinely forward-looking ergonomic features into the design.
Oh, really? Like what?
Yeah, they were clearly thinking about user convenience, even within that budget enclosure. For instance, they finally included an LED status indicator.
Ah, right. A little light to tell you if it's on or off. Seems basic now, but back then.
Not guaranteed at all, especially on a budget pedal line in 1981. Many competitors still expected you to just listen for the effect to know if the pedal was active.
Which isn't always easy on a loud stage.
Exactly. So providing a bright, clear status LED, along with that really prominent large rectangular treadle switch.
Yeah, that big stomp pad thing.
Right. Made it easy to activate, easy to see if it was on. It showed they were still focused on the player experience, despite the cost cutting.
And you mentioned another ergonomic win, something about the jacks.
Yes, and this is a detail that I think speaks volumes about how they were thinking about the future, even if it was housed in cheap plastic. It's the crucial design choice of having top-mounted input, output, and power jacks.
Ah, okay, so all the plugs go on the top edge, not the sides. Why is that significant?
Think about pedal boards. By the early 80s, players were starting to use more pedals, building denser boards. Side-mounted jacks eat up valuable real estate. You have to leave gaps for the plugs.
Right, the pancake plugs hadn't quite taken over yet either.
Exactly. So by placing all the connections on the top edge, you could butt the pedals right up next to each other, side by side, saving space.
That's actually pretty smart. It anticipates the modern pedal board layout by decades.
It really does. They were clearly paying attention to the emerging needs of gigging musicians, even while wrestling with this budget constraint. Very forward-looking, ergonomically.
Okay, so they optimized for space, visibility, and manufacturing efficiency. But there's always a but, isn't there? This is where we need to dig into the trade-off. What was the Achilles heel of this construction? Why does this series have such a, notorious reputation among repair techs today?
It comes right back to that central cost-saving architecture. The PCB-mounted hardware.
The jacks and pots being soldered directly to the board.
Exactly. Think about a traditional heavy-duty MXR pedal in a metal box. If a guitar cable gets yanked accidentally, or you step on the plug.
The force goes into the metal jack, which is bolted to the sturdy metal case.
Right. The force is absorbed by the chassis. The circuit board inside remains pretty well shielded from that physical stress.
But in the Commande series, the plastic shell doesn't offer that kind of support, does it?
Not at all. When you stop that large treadle switch, maybe a bit too enthusiastically or more commonly, when a cable plugged into one of those top jacks gets stressed, maybe someone trips over a cord, or you just wiggle it the wrong way.
Oh.
That force, all of it, is transferred directly and entirely to the small copper traces and solder joints holding that jack or pot onto the PCB. The Lexan shell provides basically zero structural support for those components.
And solder joints aren't designed for mechanical stress.
Absolutely not. The result, as you see cited universally in repair logs and forums discussing these pedals, is cracked solder joints, or even broken copy traces on the board itself.
Leading to intermittent signal, or just silence.
Yep. The whole unit becomes unreliable, intermittent, noisy, or just dead silent. It's the #1 failure point.
Wow. So the very design choice that made them compact and cheap to manufacture the direct PCB mounting is precisely the reason they tend to fail under real-world gigging conditions.
It's the primary mechanical flaw, without a doubt. And on top of that, the large treadle foot switches themselves are also known for becoming noisy or intermittent or just plain sticky with age and, dust getting in there.
So they really were built with a limited lifespan in mind, almost functionally disposable.
That seems to be the implication. Longevity was clearly sacrificed for that initial price point. They needed to compete now, even if it meant the pedals wouldn't last forever.
Okay, one more crucial construction detail before we get into the individual pedals. Power. Because this is where a modern user trying to fire one of these up could easily make a costly mistake.
Well, absolutely critical. Power specifics are vital here. Like almost all pedals from that era, they run on a standard 9-volt source, either a 9V battery inside.
Which fits under that treadle, I assume.
Correct. Or an external DC adapter. However, the DC jack itself uses that smaller 3.5mm or 18-inch plug, like old headphone jacks.
Right, not the standard Boss-style barrel plug we see everywhere today.
No, which is uncommon now. You need an adapter. But the really dangerous detail is the polarity.
Ah. Most modern pedals, at least in North America and Europe, run on a center-negative polarity. The middle pin of the barrel plug is negative. What did MXR use for the Commande series?
Crucially, many listings, and often the power diagrams printed on some of the units themselves, specify positive tip or center positive polarity.
Center positive, the opposite of today's standard. Why?
It wasn't a random choice. This polarity, center positive, was actually common on many early Japanese imports, like Boss pedals from that specific era, the very pedals MXR was directly competing against.
So they adopted the competitor's power standard to make it easier for people who already had those power supplies.
That seems to be the logic. By adopting that standard, they made their new budget pedals compatible with a different segment of the market's existing power setups. Smart, in a way.
But potentially disastrous now. If you, the listener, were to accidentally plug a modern standard center negative power supply into one of these vintage positive tip Commande pedals.
PFT, instant smoke. You can easily fry the internal circuitry. Reverse polarity protection wasn't always standard back then, especially on budget gear.
Wow. So always check the label. Or use a battery.
Absolutely. Always check the internal polarity diagram if it's there, or consult reliable sources online. And if in doubt, use a dedicated, correctly wired power source or just stick to a battery. It really underscores the era. MXR was trying to adapt to the new market reality set by Japanese competitors, but in doing so, they created a specific compatibility hazard for modern users.
Okay, so fragile construction, potentially tricky power.
Let's see if the sounds inside were worth the hassle. Let's move into the utility core, section 2. These are the first 3 pedals in the series, designed for handling signal dynamics and drive.
Right. We begin with the M162 preamp. Now, on paper, this was MXR's budget clean boost, designed to do basically the same job as their legendary single-knob M133 microamp, which was already a classic, a staple on tons of boards even back then.
Absolutely. Just a simple volume boost. But, as you kind of hinted at earlier, the budget Commande version actually came with a feature set that many players preferred over the original classic.
How so? What did the M162 have?
The M162 sports 2 controls. Gain, like the microamp, but also a tone control.
Gain and tone. What did that extra tone control allow players to do that the single knob microamp couldn't?
Well, that tone control was actually a massive functional upgrade. The microamp just gave you more volume, a boost, which is useful, sure.
But sometimes a boost can make you sound muddy or maybe too sharp.
Exactly. If your boosted signal sounded too thick or too shrill with the microamp, you were basically stuck. The M162's tone control, however, allowed for this subtle but really crucial equalization sweep.
So you could use it not just for more volume, but for actually shaping the character of the boosted sound.
Precisely. If you were playing live, and maybe your sound got lost in the mix when you kicked in the boost for a solo,
you could dial in a bit more treble with the tone knob to cut through.
Exactly that tone sweep capability. Or conversely, if you wanted to add a bit of warmth to a bright single coil guitar when you boosted it, you could roll off some of the high end. That simple 2-knob setup made the M162 inherently more versatile for actual live use than its single-knob predecessor.
Interesting. So people might have actually preferred the cheaper plastic preamp over the classic metal one.
Many users did, specifically because of that added versatility. It really justifies its popularity among players at the time, beyond just the price.
That raises a fascinating point about budget line design, doesn't it? Sometimes the need to simplify and repackage can actually lead to unexpected feature improvements.
It happens. Constraints can breed creativity.
And speaking of unexpected, we need to talk about rarity here, because not all M162s look the same, do they?
No, they don't. The M162 is one of the 2 pedals in the Commande series that has been cited and documented in a rare white case variant.
White plastic instead of the standard black.
Yes, alongside the standard black Lexan shell. We suspect these were probably either very early prototypes, maybe, or perhaps extremely limited production runs, maybe for specific promotions or regional trials.
So finding one now.
Oh, it's tough. Today, a functioning white case M162 preamp commands serious collector attention. They often sell for a substantial premium, far exceeding its original budget price point. A real collector's piece.
Wow. Okay, next up in the utility section, the M163 Sustain. Now, the name implies, making notes last forever, but in reality, this is MXR's budget take on compression, right?
That's exactly what it is. It operates as a compressor limiter, controls the dynamic range of your guitar signal, squashes the loud parts, boosts the quiet parts, which increases the perceived sustain.
Makes sense. What are the controls in this one?
Just 2 again. Output for the overall level, and sensitivity, which controls how much compression is applied. Pretty standard compressor controls.
And technically, how did they achieve the compression? Was it noisy, like some cheap compressors can be?
Well, if we look at the engineering, The circuitry apparently uses a transistorized rectifier scheme, which technically speaking is generally a pretty low-noise way to handle the detection of the signal level that triggers the compression.
Okay, so the technical commentary suggests the resulting action is relatively smooth and low noise. That sounds pretty good for a budget unit.
It is. It's generally well regarded for being quite transparent.
But was there a trade-off? I mean, if this was a budget unit, surely it couldn't compete with, say, their Dynacomp, or was it maybe just included to sort of check a box, we need a compressor in the line?
That's a fair question. And yeah, if you compared to a high-end studio compressor, or even the Dynacomp, which has its own strong character, there's a trade-off. Technical reviews back then, and user reports since, note that the range of control was somewhat narrower than some other units. Meaning it doesn't give you that super aggressive, heavily squash, country chicken picking sound, or the extreme limiting may be needed for certain funk rhythm styles.
So it's not a dramatic, effect-heavy compressor.
Yeah.
More subtle.
Exactly. It's not a workhorse compressor in that sense. But again, for a low-cost line in the early 80s, delivering a smooth, reasonably transparent, and genuinely low-noise compression effect, even if it was a bit subtle, was actually a significant achievement.
Okay.
It provided usable dynamic control, leveling things out, adding sustain, without introducing a ton of the hiss and noise floor issues that often plagued cheaper compression circuits back then. So it was a functional, quite gentle tool.
And like the preamp.
Yes, like the preamp, the M163 sustain is also documented in that rare white case variant, making it similarly a highly sought-after collectible today. Finding a white sustain is probably even harder than finding a white preamp.
Wow, okay, so 2 white whales in the utility section. Finally, in this core group, we arrive at the M164 Overdrive. Now, this pedal carried a pretty heavy weight for the series, didn't it?
It certainly did. This was MXR's sole budget dirt pedal for the entire Commande lineup.
No separate distortion pedal in this series.
Nope. Crucially, MXR opted not to include a dedicated distortion pedal in this low-cost line, which meant the M164 Overdrive had to handle everything from, barely there clean boost with just a hint of breakup, all the way up to saturated rock grit.
That's a lot to ask from one budget pedal. What were the controls?
Again, super simple and standard, output for level, and distortion for the amount of drive. That's it.
Okay, so since this was MXR's affordable drive option, how did it actually sound compared to its famous metal box contemporary, the legendary MXR Distortion Plus Wurmser, that bright yellow beast?
Yeah, that comparison is really key to understanding the M164 sonic fingerprint. The Distortion Plus is famous, or infamous depending on your taste, for using hard diode clipping. That results in a really kind of fizzy, gritty, highly saturated sound, often described as almost fuzz-like, quite aggressive and very compressed feeling.
Randy Rhoads territory.
Exactly. The M164 Overdrive, in contrast, tends to be much smoother, generally more transparent, meaning it lets more of your original guitar tone through, and overall, it's a lower gain pedal.
So if you were looking for that classic 70s hard rock or early metal saturated sound, the M164 probably wasn't the ticket.
No, definitely not. It was positioned and generally sounds like a true overdrive, meaning it was designed more to push the front end of a tube amplifier into breaking up naturally, or to provide a more subtle, tube-like breakup simulation on its own at lower volumes.
More like a tube screamer competitor, maybe, than a distortion plus competitor.
Sonically, that's a much closer comparison, yeah. Contemporary listings and ads explicitly positioned it as the low-cost Lexan series counterpart to MXR's heavy-duty dirt pedals, like the Distortion Plus One. It offered an accessible entry-level drive option that clearly favored clarity and subtle grit over full-on heavy saturation.
Which makes sense, actually. It gives it its own niche.
Exactly. That clear difference in sound profile helped justify its existence alongside the premium metal offerings, even during that intense budget pressure. It wasn't just a cheaper D plus one, it was a different flavor of bird altogether.
All right, that covers the utility pedals. Now, let's move into section 3, time and space. This is where it gets, I think, really interesting.
Agreed.
Because when a company is cutting costs right down to the chassis material, you kind of expect them to stick to simple drive and boost circuits. But MXR actually housed some genuinely sophisticated, complex analog technology inside these plastic shells. They tackled modulation and time-based effects.
Yeah, this is where the engineering team really shines, I think. It proves that the circuit design talent at MXR was still absolutely top tier, even if the budget was dictating the enclosure.
So first up in this group, the M161 phaser.
Right. A standard-looking two-knob unit, controls for speed and region or regeneration feedback. Pretty typical phaser controls.
Okay. The specs tell us a bit more, though. The sweep rate is listed as going from a really slow 0.1 hertz all the way up to a pretty fast 9 hertz.
Wide range.
And it had a high input impedance around 800K, which is good for preserving your guitar's high-end frequencies. But what about the sound? Phasing circuits are notoriously sensitive to their internal design. Was this just a cheap Phase 90 clone in a plastic box?
No, not at all, actually. And this specific circuit reveals a really fascinating technical decision MXR made. While the classic Phase 90, the script and block logo ones, famously uses an optical circuit with light-dependent resistors or Vactrols for the modulation control.
Giving it that smooth, chewy sweep.
Exactly. Some technical threads and deep dives into the M161 phaser identify that it utilizes MXR's much less common switched resistor approach.
Switched resistor. That sounds almost digital, even though this is definitely an analog circuit. What does that mean practically? How does it affect the sound?
Well, it involves the use of CMOS integrated circuit chips, specifically things like the 4066 or 4016 quad bilateral switch chips. These function essentially as tiny electronic switches controlled by the LFO, the low-frequency oscillator. So instead of the continuously variable resistance you get from a Vactrol circuit, which creates that super smooth, liquidy sweep, the switched resistor approach modulates the phase stages by switching different resistor values in and out of the circuit in slightly more discrete steps.
Ah, okay. So what does that actually sound like? Is it a noticeable difference? Can you hear those steps?
Yes, subtly, but it's definitely there. This architecture often results in a phaser that sounds a little, maybe choppier, or perhaps more distinct and almost motor-like at faster speeds. It's less of that super creamy, chewy, syrupy sweep associated with the classic Phase 90.
A different flavor of phase.
Exactly, a unique flavor. One that MXR apparently experimented with in a few select circuits during the early 80s, possibly as a way to achieve phasing with cheaper or more readily available components than Vactrols. It marks the M161 as a bit of a sonic outlier in their overall modulation catalog.
Interesting, right. Very interesting. Okay, moving from phase to time. The M166 time delay. Now, this pedal represents a really clear commitment to analog, even in the budget line, right? Because this was happening just as digital delay technology was starting its aggressive rise.
Absolutely. Digital's coming, but MXR doubled down here and went with true analog bucket brigade device BBD technology.
BBDs, the heart of classic analog delays and choruses.
Yep, and the key detail here of the chip they used is the venerable Redicon SAD4096 chip.
SAD40096. What's significant about that specific chip?
For those unfamiliar, BBD chips work by passing the audio signal along a chain of thousands of tiny capacitors, like a microscopic bucket line, delaying it at each stage. The number of stages the length of the bucket brigade determines the maximum possible delay time. The SAD4096 was significant because it had 40 or 96 stages.
Which was a lot for a single chip back then.
It was, especially for a pedal aiming at a budget price point. The M166 earned a reputation pretty quickly because that SAD4096 allowed it to achieve surprisingly long maximum delay times for a single chip BBD unit of that era. We're talking, potentially several hundred milliseconds.
Which sounds great. Longer delays are useful, but pushing analog BBD technology to achieve longer delay times usually comes with a trade-off, doesn't it?
An unavoidable side effect, signal degradation. As the audio signal travels through all those thousands of tiny capacitor stages, it naturally loses high-frequency content. It picks up clock noise from the chip's timing circuit. It gets messy.
And that degradation, that messiness, that's what defines the sound of vintage analog delay.
It absolutely does. That inherent technical trade-off is precisely what results in the pedal's characteristic dark, lo-fi voice. The repeats aren't crystal clear like digital. They're warm. They sound filtered. They get progressively muddier with each repeat.
Which is exactly why vintage delay fans seek these things out today, right? For that warmth.
Precisely. It provides that distinctive, warm, almost decaying analog wash that digital units often strive, and, many would argue, often fail to replicate faithfully. It's got character.
What are the controls on the time delay?
Pretty standard stuff. A delay knob for setting the delay time, and a region knob for controlling the number of repeats, from a single slapback echo all the way up to runaway, oscillating self-feedback if you crank it. Classic delay controls.
Okay. Now, as a repair tech, or even just someone poking around online forums, I've heard rumors about a sort of hidden adjustment on this particular pedal, something not obvious from the outside.
Yes, and this is another one of those cool little details where the engineers seem to be trying to maximize versatility despite the external budget constraints.
Yeah.
Some units apparently not all, but many, have a small trimmer potentiometer, a little adjustable screw located inside the battery bay.
Inside the battery compartment, what does it do?
It's reportedly a wet-dry mix trimmer.
Wait, a mix control that you can't actually access from the outside of the pedal? That's odd.
It is odd, but apparently it's there. A tiny little pot hidden away under where the battery sits. It allows the user to fine-tune the internal blend between the delayed wet signal and the original unprocessed dry signal.
So you could set it internally for how prominent you wanted the echoes to be overall.
Exactly. This provided some unexpected extra sonic versatility beyond just the external delay and region controls. You could potentially set the pedal for a very subtle blended ambient wash by turning the internal mix down, or crank that internal mix way up for a much more pronounced, almost 100% wet echo effect if you wanted.
That's actually a really neat, if slightly inconvenient, hidden feature. A genius piece of hidden engineering for a budget box.
Yeah, it suggests they were really trying to pack value in there.
Okay, that's a great discovery. Now for the final two pedals in the series. And both of these demonstrate truly ambitious engineering, especially for a cost-constrained series, because they both offered true stereo functionality.
Which was a huge deal back then, especially in a budget line.
Let's start with the M167 stereo chorus.
Right. Also BBD-based, like the delay. Some sources mention it using the SAD 512 chip, which is a shorter BBD, more typical for chorus effects. The external controls are, again, simple. Just speed and depth for the chorus modulation.
But the headline feature, as you said, true stereo outs, 2 output jacks. This is a massive selling point in a pedal from 1981, offering that huge, spacious, wide sound field.
Absolutely. Stereo is becoming a big thing in studios and for some live rigs.
So how did MXR actually achieve genuine stereo spread inside that small, cost-effective Lexan shell? Usually, a true stereo chorus requires some fairly complex signal splitting and phasing circuits, doesn't it? It's not just splitting the output signal.
No, exactly. A simple Y-split output just sends the same mono signal to 2 amps that's not true stereo. To create that real sense of spatial width, the signal needs to be processed differently for the left and right outputs, usually involving phase manipulation.
Okay, so how did they do it cheaply in the M167? What did the gut shots show?
Well, MXR employed a clever and, importantly, cost-efficient technical solution. The unprocessed dry signal remains in phase and is present on both outputs. However, the modulated wet signal, the chorus part generated by the BBD, that wet signal is processed, and then, crucially, an inverting buffer circuit is used on one of the outputs.
An inverting buffer? What does that do?
It takes the modulated wet signal and flips its phase by 180 degrees before sending it out of that second output jack.
Ah, so one output jack gets dry plus normal phase wet signal, and the other output jack gets dry plus inverted phase wet signal.
Exactly. When these two slightly different signals, particularly the out-of-phase wet components, hit 2 different amplifiers or speakers.
The phase cancellation and addition between them creates that wide, swirling, spacious chorus effect, that sense of movement between the speakers.
That's precisely how it works. It's a very effective and relatively simple way to achieve true stereo chorus. A real testament to the efficient engineering they managed to maintain, even under the pressure of this budget line. They didn't just slap a stereo label on a mono pedal.
Very impressive for the time and price point. Okay, finally, the last pedal in the Commande series. The M168 stereo flanger.
Right. This was the Commande series' answer to stereo flanging. Again, providing that wide spatial effect, but with the characteristic swooging jet plane sound of a flanger.
What were the controls on this one?
Standard flanger controls, speed for the rate of the sweep, and region for the intensity or resonance of the flange effect. Pretty much what you'd expect.
And stereo outs, again, presumably achieved in a similar way to the chorus.
Presumably, using a similar phase inversion technique on the wet signal for one of the outputs, yes. The key structural note here, though, is that sources mentioned it was designed to be mechanically simpler and likely cheaper to build than MXR's flagship, heavy-duty, larger metal M117 flanger pedal, which is also available around the same time.
Right. The M117 was a big, complex, mains-powered beast, wasn't it?
Exactly. So the M168 offered a simpler, battery-powerable stereo flanging option at a lower price point.
So structurally weak, maybe?
Yeah.
But sonically solid, offering genuine stereo, much like the theme emerging for this entire series.
Precisely. The effect quality, by all accounts, was solid. The stereo functionality was the real deal. But yeah, the plastic chassis and those PCB-mounted hardware components were the acknowledged strategic weak points. The Commande series consistently housed real analog ambition inside a shell built out of mechanical compromise.
Okay, let's move into section 4 then. The collector's corner and the overall legacy of this short-lived series.
Right.
We've established pretty clearly that this series was, well, maybe a structural disaster waiting to happen, born out of sheer budget desperation. But time is a strange thing, isn't it? Because today, 40 years later, these plastic pedals are actually highly sought after by collectors.
It's true. They are.
What drives the collectability of a line that was explicitly designed to be cheap and maybe disposable?
Well, I think there are two main drivers here. First is the historical significance they represent this specific critical moment in MXR's history. And second is the technological scarcity, especially concerning certain models.
We should probably expand on that rarity factor again, focusing particularly on those incredibly scarce white case variants we mentioned earlier, the M162 preamp and the M163 sustain.
Definitely.
Why are they so rare? Was it just a color option?
It doesn't seem like it was just a standard option. Given that the entire production run of the Commande series was so short, only about 3 years before MXR closed in 1984.
Right, not a lot of time to make huge numbers of anything.
Exactly. So we believe the white cases represent extremely limited production quantities. Perhaps they were intended for early advertising shots, or maybe specific regional sales pushes that never fully materialized. Or maybe they were just pre-production units that somehow escaped the factory.
So their scarcity is extreme.
It really is. Yeah. Which completely transforms what was originally a budget item into a highly desirable trophy piece for serious collectors. Owning a functioning white case Commande pedal today is a genuine achievement for MXR enthusiasts. They're definitely holy grail items within the series.
It creates this really compelling, almost tragic dichotomy, doesn't it? A series that was built to be affordable and easily replaced has now become valuable precisely because of its scarcity and, ironically, its internal complexity.
Yeah. We really have to connect the dots between that initial budget purpose and the long-term collectability. It's fascinating.
It really is the ultimate expression of the compromises forced by 1980s manufacturing realities, isn't it?
I think so. This series offered surprisingly sophisticated analog circuits.
Yeah.
You had the SAD 4096 BBD delay chip capable of long repeats. You had true stereo effects in the chorus and flanger using clever phase inversion. You had that unique switched resistor phaser topology.
Circuits that arguably belonged in the premium heavy-duty metal enclosures that MXR was famous for.
Absolutely. Yeah. But MXR made a very conscious, strategic decision to sacrifice mechanical endurance almost entirely to achieve that necessary lower price point to compete with the imports.
So the plastic shell wasn't a mistake or bad design in that sense. It was the unavoidable cost of trying to survive in that market.
Exactly. It was the strategic burden that the engineering department had to work within. They delivered high-quality analog effects, impressive stuff for the price, but the accounting department, or market reality, mandated that fragile shell.
Which brings us back to the timeline and the end of the story for original MXR. This 1981-1984 production run was extremely short. It really represents the last gasp of the original company, doesn't it?
It does. MXR was clearly losing the budget war. They tried this plastic line, the Commande series, and when that didn't fully stop the financial hemorrhage, they immediately tried to pivot back towards perceived quality.
How so?
Well, by 1984, they shifted away from the plastic Commande line entirely. They introduced the all-metal series 2000 pedals. Things like the Dynacomp, Distortion Plus Face Maze 90 were reissued in slightly updated, but still very rugged metal enclosures. They were attempting to restore the brand's image of durability and quality.
A return to their roots, in a way.
Kind of, but the market had changed too quickly. The financial damage from the preceding years was likely too deep, and the attempt with the Series 2000, while producing some great pedals itself, was ultimately just too little, too late.
And the original MXR company closed its doors.
Later that same year, in 1984, shortly after launching the Series 2000 and discontinuing the Commande line.
Wow. So the Commande series really is this brief, intense, and technically ambitious artifact of a legendary company fighting and ultimately losing a brutal market war.
That's a perfect summary of its place in history. So if we try to synthesize this whole deep dive, the MXR Commande series really stands as this fascinating snapshot, a picture of a company desperately trying to balance its legacy of classic high-quality analog circuit design with the, frankly, brutal realities of mid-1980s manufacturing economics and overwhelming global competition.
Yeah.
They designed and produced some great sounding circuits, genuinely impressive analog stuff for the era. But they were forced by the market to house them in these cost-effective but inherently fragile plastic shells.
So what does this mean for you, the listener, whether you're just curious about pedal history or maybe you're actually thinking about hunting one of these down?
Well, it means you can access genuine vintage analog tone from a legendary brand. You can get that beautiful, dark, lo-fi BBD delay voice from the M166. You can get the smooth, low-noise, transistorized compression from the M163 Sustain. You can get that unique, slightly choppy switch resistor phaser sound from the M161.
That's great.
But that access demands respect and, honestly, a lot of caution. Due to those inherent mechanical weaknesses, the plastic construction, and most critically, the PCB-mounted Jackson pots, these units simply cannot be treated like a vintage metal box MXR pedal. You can't just stomp on them carelessly or throw them in a gig bag.
Right. Handle with care.
Absolutely. They demand careful use. They demand very careful power supply choices. Always double-check that polarity. Remember the positive tip possibility. And they probably require routine maintenance, opening them up periodically to check for and reflow those inevitable cracked solder joints around the Jackson switches.
So they are genuine analog treasures, but they're housed in a structure that was basically built to fail under stress.
That's the paradox. Analog treasures in fragile shells.
And that structural fragility, ironically, is the key to understanding their history, isn't it? The Commande series shows so explicitly that sometimes a product's greatest vulnerability in this case, the defining Lexan plastic shell, is a direct, non-negotiable result of intense market pressure and the desperate need for innovation under severe budget constraints.
Absolutely. It wasn't an oversight. It was a calculated sacrifice. Which leads us to our final provocative thought for you, the listener, to maybe explore on your own.
Go on.
The Commande series proves that cost constraints often dictate form, sometimes overriding even internal engineering brilliance. So think about the legacy of other products, maybe in music gear, maybe in electronics, cars, anything really, where the single most criticized structural or material decision ended up defining an entire product line, even if the internal technology or performance was actually top tier for its time.
Was that trade-off ultimately worth the short-term survival it might have offered the company? What defines a product's legacy more in the long run? Its internal circuit brilliance or its external structural fragility?
Something to ponder.
That's a deep question to consider the next time you look at, well, any plastic enclosure, really. That's been our deep dive into the fascinating and fragile MXR Commande series. Thank you for joining us.